Hello, my darlings. Today we are going to be looking at the structure of the universe. By the end of this lesson, you should be able to identify the comparative scale of the parts of the universe and identify what lies at the center of each of those parts. Now, when we say comparative scale, right, remember that word we talked about, compare? So if you're comparing one part of the universe to another part, how does it compare, for example, in size to the other parts? The first thing we are going to be looking at is the universe. Verse. Now, here is an image that is kind of an artistic rendition of some parts of the universe. So let's take a look at this. Now, for these notes, you have this paper here. In this outer ring, this is where you are going to write your first bit of notes here about the universe. When you're done, it's going to look something like this. So when we talk about the universe, we're talking about the biggest part of space. This includes all matter and space that exists. When we say matter, that's a really great science word that you're going to see again and again, especially next year. Matter is anything that takes up space and has mass. Now, in addition to normal matter, the universe is also made up of some really crazy stuff called dark energy and dark matter. Now, the universe has an age, just like you have an age and I have an age, and the universe is about 13.8 billion years old. It's mostly empty space. So even though we mentioned that you have matter up there and you have dark matter and you have dark energy, most of what it is just empty space. Now, the universe is at least 10 billion light years in diameter. So if you remember back to math, right? If we look at something like this, diameter would be from this side to this side, all right? Now, 10 billion light years doesn't really mean a lot, but billion is a big number. And to give you kind of a point of reference, one single light year is exactly 9,460,730,472,580.8 kilometers. It's huge, and that's just one single one. So you're taking that number and multiplying it by 10 billion. That is craziness. There are billions, maybe more, galaxies and trillions of stars in the universe. And the universe is constantly expanding. It's not sitting still. It's actually getting bigger every single second. Now remember that one of our success goals is to identify what's at the center of each part in the universe. The universe, though, actually has no center. Now, if we zoom in a little bit more, the next thing we're going to see is a galaxy. Galaxies are smaller than the universe. Here's an image where if you were to just look up into the sky, you would just think it's a bunch of stars. But actually, when you get a really good high rendering of these, you can see that each of these things that looks to be like stars is actually a galaxy. This is a picture of our galaxy. Woohoo! We live here. Now, the cool part with our galaxy is that even when you're on Earth, you can actually see our galaxy. This thing right here that kind of looks like milkiness in the sky, that's you looking out at the rest of our galaxy. Now, galaxies have lots of different types. There's elliptical galaxies, irregular galaxies, spiral galaxies, barred spiral galaxies. They're really pretty numerous. The notes that we are going to take on this are going to go in this second section. So you are going to be writing in this spot this time, just like you did for the first. Now, what's some information on galaxies? Well, what is a galaxy in the first place? A galaxy is a cluster of stars, gas, dust, and matter. The size of the galaxy depends on the number of stars that it contains. Now, it's really hard, actually, for scientists to predict how many galaxies there are. It's not something where we're actually going through and we're counting all of them. So scientists estimate that there's anywhere from 200 billion to 2 trillion galaxies just in the known universe. That's what we can see. Our planet is in a very special galaxy called the Milky Way galaxy. But a couple of other galaxies, there's lots of them, but a couple other that I think are really cool that we do have names for are Andromeda galaxy, antenna galaxies, and I'm going to get to why that is in a second, and butterfly galaxies. Now, again, remember, one of our success goals is what is at the center of each of these things? Well, at the center of galaxies, it's not a star, it's a black hole. And we're going to get into more about what that means later, but this in and of itself is awesome. Now, just so you guys can see some examples, this here is Andromeda Galaxy. You can see that Andromeda Galaxy looks a lot like the Milky Way galaxy. This one here is Antenna Galaxies. Now, this one's awesome. Now, it's called Antenna Galaxies because it looks kind of like an antenna on like some kind of like animal, right? But actually, the reason that this looks so crazy is it's not just one galaxy. Nope. It's two that are colliding with each other, which is so awesome. So galaxies can actually run into each other. Here we have butterfly galaxies. It's the same thing. It looks like it's called butterfly because it looks like, you know, a butterfly. But these are, in fact, also two galaxies. Here's Galaxy 1 and Galaxy 2 that are in the process of colliding with each other. Now, smaller than a galaxy is our next thing, planetary systems. Now, lots of times when we think of a planetary system, we think of the solar system, our planetary system. But there's actually lots of different planetary systems. They all have really, really bizarre sciencey names like TRAPPIST-1 system, Kepler-90 system. You can see here that we have the 51 Pegasi, we have 55 Cancri, we have Carrot 7, we have TOI 270, and all of these have different kinds of planets that sometimes are similar to ours and sometimes are quite different. Now, again, just like with our other things, you are going to be writing this in its own section, so anything you write down for this one is going to go in this section here. Now, planetary systems are defined as stars that are orbited by planets. So you have a star like the sun, and then going around that star, you have different planets. Planets are held in place by the gravity of the star, and we're going to talk more about that later. Earth with 7 other planets and the sun, we call that the solar system. So you don't say there's many solar systems in the universe. There's only one solar system, but there's many planetary systems. Now, the last thing, again, we want to know what's at the center of a planetary system. Well, at the center of a planetary system is a star. It can be one or more, though. If you've ever watched Star Wars and there was that one scene where they have like one sun that's like kind of going down and then like another sun, some planetary systems, in fact, do have more than one star at the center. Which leads us to our last category, stars and planets. Now, we lots of times will just think of our star and think, oh, well, all stars are probably like that. But if you've looked into the sky, you've probably seen a bunch of different colors. And sometimes you see different colors because those are planets, actually, and not stars. But sometimes it's because stars have different colors, too. So you can see this is a red giant. This is a blue giant. This is a white dwarf. This is a red dwarf. This is a brown dwarf. Now, fun fact. Which of these do you think is the hottest? So the hottest star actually is not a red star. It's a blue star. Blue stars are actually the hottest stars. Now, just like there's many different types of stars, there's also many different types of planets. We have terrestrial planets, giant planets, satellite and dwarf planets. Now, you have a pretty small section for this part here. This is where you're going to be writing this info. So do make sure that you write a little bit small for this part. So one thing to keep in mind is that stars are greater than planets. And I don't mean that like, go stars, boo planets. Like what I mean is that stars are just genuinely much, much bigger than planets are. And that's even true for our largest planets. You can fit 1,000 Jupiters inside of the sun. And the sun is actually a really small example of a star. Stars are spheres of something called hot plasma. And we'll talk about that idea a little bit more later, but that's all you need to know about it for now. Planets, on the other hand, are spheres of rock or gas or liquid? And again, we really want to kind of focus on that lens of what's at the center of these things. So at the center of stars and planets is something called a core. And we're going to look more at that later.